Hi everyone. In today's session, we are going to see the problem of disk scheduling and a operating system. We have already seen what is disk scheduling, and we have already said there are 6 types of disk scheduling. And in previous sessions, we have seen the types of FCFS, SSTF, and SCAN in solving the disk scheduling problems. In today's session, we are going to see about C-scan. The C-scan stands for cylindrical scan. It is similar to the scan as in scan we have seen the technology that from the head position the serving will be started in a cylinder, and till the uh, from if it start traversing in one end, it will provide all the request in one side, and after touching the end of the cylinder, then in reverse, while returning, it will serve other request. This is the concept of scan. Okay, for that we have seen this problem as an example. In C scan, it is similar to the scan, but the thing we are facing in scan is that, as said, in scan, while returning from one edge, it will be start serving, right? If we consider the scenario of uh, if another if already some requests are in the queue, and while returning another new request arrived and it was in the space of the returning, if we consider this scenario, then while returning it will serve all the new requests, and the pending request will be having more waiting time. So this is unfair, right? Because the uh, first requested process will be waiting for too long time. So for avoiding this scenario, we are possessing this C scan, that is cylindrical scan. This is nothing but it is similar to the scan technology. In this, the head moves to the one end of the cylinder, and after reaching the end of the disk, it won't serve the request while returning to the another end. It will come to the another edge, and after uh, reaching the another edge of the cylinder, it will start serving the request. Okay, it considers the disk as an cylindrical manner. So after completing on one side, it will come to the another end of the disk, and while returning only, it starts its serving. This is the concept of cylindrical scan. Okay, let's see this with an example problem. Okay, and this is the example problem which we have seen for the previous 3 techniques. We are seeing this problem under the same example. In this, there is a request queue for serving, and the queue is 98, 183, 37, 122, 14, and 124, and finally 65 and 67. And the initial head position of the cylinder is at 53. And in this, since it is a cylindrical scan, as said, it is similar to the scan, we can start the uh, providing of the request in either left or right direction. That is our choice. Okay, in this C scan, we are moving towards the right from left to right. After that, we are traversing the whole cylinder for at once, and we are again solving this from left to right. Even though you can use the path of traversing from right to left also, that is your convenience. Whichever the path you are taking, you must serve all those requests in this path. After touching the edge, you must traverse to the another edge, and while returning only you have to traverse. This is the concept of C scan. As I said, I am taking from left to right. Okay, so the first head position is at 53, and in the starting itself I have mentioned all the request queues in between the position. In this problem, the total cylinder count is given as 200. So I am taking the limit from 0 to 199, and after that I have mentioned all those cylinder head position. Just wait a second. Okay, in this, here it is 98, and after that 183 I have mentioned it. After that it is 37, it is may also mentioned, and 122 it is given, followed by 14 and 124, 65 and 67. Okay, this is a total request pending. As I said, if we start in one direction, it will serve all the requests in that direction, right? I am taking from left to right. From 53, I am moving to the 65. Then from 65, the disk moves to 67. After 67, the request of 98 is served. And after 98, 122 is served. After 122, 124. Then after 124, 183, and after 183 finally, since as I said it must touch the end of the another cylinder, so it goes for 199, it is the end of the cylinder and end of the disk. After touching 199, it returns back to the another end of the disk, that is from 199 it moves to 0, and from that, while returning, it will change the direction and it will serve the balance pending request. So from 0 it goes for 14, and from 14 it finally provides request of 37. So finally all those requests are completed. In this we have to find the total head movement of this cylinder, right? In this we can calculate the head movement as said by calculating the difference between each and every point, that is from 53 to 65 the distance traversed is 12 cylinders, and from 65 to 67 it is of 2 cylinders, and from 67 to 98 it is 31 cylinders, and from 98 to 122 it is of 24 cylinders, and from 122 to 124 it is of 2 cylinders, from 124 to 183 it is of 59 cylinders, and from 183 to 199 it is of 16 cylinders. Then we are returning back from 16 to 199 to 0, so the total 200 cylinder movement. Then finally from 0 we are providing for 14, right? It is of 14, and from 14 to 37 it is 23. The total cylinder movement will be of sum of all these values, it is around 383. So this is the total. You can calculate in this way, or else you can calculate the total distance from 53 to 199. You can take the whole stitch distance. It is more easy than this. Okay, from 53 to 199 it is of totally 146 cylinders. From 199 to 0 it is of 200 cylinders, and from 0 to 37 it is of 37 cylinders. So the total is of 383 cylinders. So the total head movement for solving this request queue under C-scan technology is C-scan algorithm is 383 cylinders. Comparatively, the cylinder movement is more in C-scan than scan. Okay, in scan we have seen it as, it's not visible. In scan the total movement is about 236 for the same problem, but while solving this we are having it as 383. This is the technique for solving this request queue under cylindrical scan algorithm for disk scheduling. Let's see the other two scheduling types, that is look and see look, in further sessions. That's it. Thank you.